Hello and welcome to another lecture on Introduction to Programming. Today we're going to be talking about custom objects. So in the previous lesson we talked about objects and objects that are built in, but we didn't talk about custom objects. We kind of just built using what was built into JavaScript. So we're going to talk about some customization that we can do to build on top of the objects that are already there. So let's go ahead and dive in, and just so you know where we're going. After I go through my lecture portion, we dive into some code. We're going to pick up from where we left off in our blog, and we're going to continue to make that more object-oriented, and we're going to throw in some custom objects to do that. So let's go ahead and just dive in and go from there. So custom objects. Custom objects allow us to get a little bit closer to object-oriented programming by building our own objects. So we can take methods that are within instances, distill them down to a single class instance, share those methods among instances rather than each instance owning its own methods. Sometimes you'll hear the term called method overloading. That's what that refers to. Now, for those of you who are just starting down this path of object-oriented programming, I want to just define a few terms. I define these early on in the semester, but I just want to clarify them and add some more visualization to them. So you'll hear me use the term class, you'll hear me use the term instance. The way we need to remember these, I like to remember them like how you build a house. So classes are blueprints. That's how we tell the program to build certain things. Whereas instances are the actual house. So imagine, for example, you have blueprints to a house. Well, you're not going to be designing new blueprints every time you build the same house in a subdivision if all the houses are the same. What you're going to do is you're going to spend the money to build the blueprints the first time, and then you're just going to use those same blueprints on every house. That's what classes are. We build the class to how it's going to work the first time, and then we instantiate instances, create instances of that class that basically will act like that blueprint class we want it to act. So we create object instances. We call them instantiation of that object. Now, I mentioned this last time, but you will see the keyword this used a lot, meaning this particular object I'm referencing to. So if in our function blog from last time we passed through the body and a date, so we had this body, this date equal to what we passed to it, and methods are owned by that instance. So every time you see the this, that's denoting ownership and locality. There's also a premise in object-oriented programming called own once, run many. Basically what that means is instance methods, they're owned by their instance, like this to string or this to HTML or whatever. And the problem with that is that you can duplicate instantiation of your methods. So let's say the to string method, that's where we took in our blog, we took our date and we chunked it down to the way we wanted it to look. Well, if we have a bunch of objects in our program, and those different objects and constructors and stuff all need the ability to turn things into a string, like the date, we will be duplicating our code. We're creating more of a maintenance nightmare for us. In fact, there's a principle in object-oriented programming called dry, don't repeat yourself. It's the opposite of wet, we enjoy typing. So what it would be better to do is to pull that to string method out of the class and out of that one class instance and create it as a part of the program. So because class methods will get shared among your instances, so they're owned by that class, run multiple times. So the way we can do this is we can use the keyword prototype. Now anytime you see the word prototype, you can just equate that to class. Okay, so what it does is instead of that to string method, or as you see on the screen to HTML method, getting owned by that one class or that one instance underneath our constructor, it is now pulled out of that constructor and it's now at the class level. So we can store it once and run it a whole bunch of times. So you've been introduced to this prototype keyword in some of the labs and accessing the data record set. So we're just kind of reinforcing it here. But that's why we do that. That way we don't have to duplicate code, and it makes things more efficient. So one of the other advantages we have to this is within our constructor. So our constructor, we can have it focus on just constructing simply our properties and things. Methods aren't being assigned to a particular instance. That takes place outside of the constructor. Our constructor is just concerned with the data, the properties, the variables, so to speak, of the actual product. So they're assigned outside. Now, just a couple syntax rules as you see on your screen there. Class names are capitalized, okay, and like constructors, and instance names are lowercase. So now, one caveat. There are JavaScript is an object-oriented language, but it plays a little fast and loose with the rules a little bit. Meaning you could easily program in not using non-object-oriented, non-OOP techniques and create a program that works. Other languages like Java and C# that are object-oriented languages as well, they are stricter in their the way that they approach things. And one of the big differences is JavaScript is an interpreted language. It has an interpreter that does it, whereas Java and C# are compiled. You take that code and you compile it into a program that runs on your computer. So there's a couple different nuanced changes, differences there. And there's not really a true support class that's concrete like Java and C#, meaning you would have in Java and C#, it would be very difficult to program using non-OOP. You'd make things harder on yourself. Whereas in JavaScript, you could play fast and loose. So what we do is we don't have any concrete part of the language that's class, so you don't have a class keyword or something like that. So we use the prototype. That's why I say that word prototype, equate it in your head to class. Now, any properties in our class, they get shared among all instances. So like in our labs that we've done, we have done used the inventory, the employee payroll records, things like that. And one of the properties in there was the position, this.position. And we use that to loop through and things like that. We could create multiple instances of like our employee payroll records. That property is shared among instances. Okay, so keep that in mind. A property it's owned by a class, it gets created within a class, a single copy. That property is made available to all instances of that class. One value shared among all. So store once, accessible to all. That has its pros and cons. You have to be careful of that. Sometimes, like in JavaScript, when you get into client-side, doing some client-side web scripting, Ajax stuff, sometimes you have to be aware of that as well, as far as how stuff is shared and not overwriting your stuff. But we can create these properties outside of the constructor with the prototype keyword, so they're at the class level instead of that instance. So they're shared once at the class level, and so every instance shares that. So in the case of this dot position, that was shared with that particular instance. So when I access and open that record data set, that instance gets access to this dot position. I create another one in my program, another instance of that. This dot position is within that constructor. But if I create a prototype outside of that, like here you see on your screen blog.prototype.signature, that is outside of the constructor. If it's outside of the constructor, then that's going to be shared among the class. So instance properties created inside the constructor, okay, and then single property, class properties outside. Okay, now one of the rules of OOP is, like I said before, don't repeat yourself. We don't want duplicate code. So anytime you see anything in your code where you're doing some of the same stuff over and over again, then you're probably heading down the wrong path. So we need to make some changes to our OOP and our code structure to reduce that. So as long as we're creating appropriate class and methods, we can reduce that. And we're going to do that in some of our code. And so we can also use the prototype object, that class thing, the prototype, to extend JavaScript classes. So we can take the string object, prototype it, the string object's built into JavaScript, prototype it, have a scramble method that could take a string of text and scramble the words all up. We would build that code inside that function literal, and then bing bang boom, we now have extended the string prototype to scramble up letters. Okay, the way we would call that is like I have down at the bottom. I have an alert as an example. Let's say our string is a signature, this dot signature dot scramble method. So we can extend built-in stuff as well. So customizing built-in objects, it helps us to make things easier. Okay, so we can format a date the way we want it to look, and that's what we're going to do in the blog. Is we had some duplication of our code up to this point with our blog, where we were having the format of our code of our date. We had it in a couple different spots, so we had some duplication there. So what we're going to do actually when we get to our blog is we're going to create a short format method within our date prototype. So a class method, so we can format that anywhere in our code that we want. So then we can also create these methods, and within our classes, these methods, and they're owned. So class methods can't access instance properties or methods, but instances can access class properties and methods. So it's a one-way communication thing. So we can create a class method. We just don't use the prototype object. We just assign the method to the class using the class name in .object notation, like you've seen me do in a previous lab or previous assignments and lectures. So what this means is like blog.showSignature, since I'm not using the prototype, other class instances cannot access that. It's encapsulated. So it's protected, it's inside my class method. So my class methods are not able to access instance properties or methods. My instance can access showSignature. So it's one way. We can also move some of that functionality inside of our class method. Again, I referred to this in the previous slide. This is an encapsulation thing, like doing the showSignature. We can encapsulate that so it protects our code and we're not accessing it and possibly mucking things up. So we can allow access to these outside the class so that they can be instantiated, but we're going to encapsulate the functionality of the object within the object itself. So we're going to encapsulate things better. Now, as we build software, one of the things we need to remember, as programmers, we are agents of change. What I mean by that is we are constantly changing stuff. We are constantly looking at software, looking at what we do, and thinking, how do I make this better? How can I make this more efficient? How can I improve this to improve people's lives or whoever's using my product? So we add new functionality, we upgrade things, we fix bugs and change capabilities, all that stuff. One of the things we need to do is we need to think through, how do we best go about this? How do we apply OOP principles and design patterns and construct this thing in such a way that it's easy to add stuff, we can update things and all that. So one of the things we're going to do on our blog is we're going to add images. Now, how in the world do we get it to add images into our blog? Well, if we think about it from an HTML standpoint, an image really is just a string. It's an image tag with a source attribute and a string in it. So we just got to have a way to grab that string and put it in an image tag. Okay. Now we're also going to make this one optional. I'm going to show you how to make it optional. So you can run through an if statement. If it has an image, put it on there. If not, don't put it on there. So we can. What this allows us to do is if we had a back-end admin area, we could allow them, whoever's doing the blog, to type the blog, put an image in there if they want one. If they don't want one, they don't have to. So the only caveat is a rule of thumb, a general accepted practice, is anything optional in our constructor, we put them last in our arguments. So put them in order of importance. So let's dive into some code here. So this is where we left off with our blog. So we could search the blog. Search for the word up. There, found it right there. And this one. We could view random entries. Remember, we did this last time. So, but let's look at what are some changes we have. So, we have our blog constructor. Now, notice what we did here. We added the blog prototype to string right here, and so we added the prototype to HTML to here. So we basically elevated these to the class level. So the prototype contains text, so we can access them from anywhere we want to be able to access them from. Okay, any instance, they're now at the class level. So we just did that with adding that prototype keyword into there. Also, I would encourage you to take a look at the unitdata.js file that's in the we've used in our labs and you've used in some of your homework, so that, or if you haven't, you will, so that you can see kind of how this prototype works, how the construction of it works. Okay, so that's all we did. Is at this point we just elevated these methods to the class level. See, as before, let me open up the previous one. Which was number 7. Make it bigger so you guys can see it. In the previous, we had our constructor here, and all this to string, this to HTML. See, it was within our constructor. So what we did was we pulled it out of the constructor. We made our constructor back simplified the way it was before, and we just said, okay, take our constructor, and I want to, at the class level prototype, make it to string function literal. Same thing with HTML. So it made our constructor easier to access and to build. So our constructor is just concerned about two things: the body and data of the blog, which makes sense. Okay. Now let's look at the next iteration and let's see where we're at with that one. So in this one we added, make it just a touch bigger, we added this little signature by Puzzler Ruby. Let's take a look at that and see how we did that. Say, constructor is the same. Let me scroll down to the HTML. The HTML is the same as it was before. Random's the same. Search blog's the same. Okay, and the actual show blog is the same, and so is the blog itself. What we did was we added this item right here: blog.prototype.signature. So we said at the class level we want to create a property called signature and call it by Puzzler Ruby. Now let's say, so in this case what's happening is this signature variable is being put everywhere. So let me highlight it here. So like here, when it's constructed, when our blog HTML is constructed, we're just adding, this dot signature, and that's at the class level. So this property is going to be shared among instances. Where this would not work is, let's say we have 3 people doing the blogging: Puzzler Ruby, Puzzler John, Puzzler Jane. Okay, so you have 3 people. You can't set this instance then, because everyone is going to be, since they all share the same instance, they all share this class level property that would be shared among those. What you would have to do is you would have to move that inside of the constructor, because it would be a property, an individual property of the constructor at that point. So now let's look at, so we added a signature there. In this case we have one lady doing it, so it's okay to do it at that level. Let's look at the 10th iteration, and let's see what we changed at the 10th iteration. Okay, at the 10th iteration we added this custom date function. So if we go back here and look at the old iteration here, we've got this toString where we're accessing the date there, and then we got it. We're doing it again right here in our blog HTML. So we have some duplication. I don't think we're doing it anywhere else. So we have some duplication in our code there, which can lead to issues. Here, though, what we're doing is we're saying, take the date object that's built into JavaScript. Let's make a custom class object out of it. We'll call it short format, and what it's going to do is return, just like we did before, the month, date, and year. So what that allows us to do then is we can say, okay, take this .date that we've passed through our constructor and just run our custom short format object method on it. So it makes our code, see, we did it again right here. So it makes it more encapsulated, pulls that code, all this code we ran before in multiple places, pulls it back into one, and all we have to do is call this short format, so that it formats our date consistently no matter where we call it from. So again, that's taking the custom, built-in JavaScript date object and just customizing it with the way we want by extending it with the prototype keyword for the class. Okay. Now, so on the surface nothing changed with that, but we just made our code easier to manage. So let's look at the 11th iteration, and let's take a look at what we did there. We got the date prototype the same, we got our blog constructor the same, our blog string, blog HTML, our contains text, our signature, sorter, our actual blog, our show blog, and search. Okay, so what we have changed, most of the stuff's the same. What we have changed going from 10 to 11 is, if you look back at 10, we have this blog.sort that's into our show blog function. However, that's not really a function of that ability to sort is not really, does not belong in show blog. Remember, I've said this in the past, SRP, single responsibility principle. A function or method should have one reason of existence and one only. The reason a function show blog exists is to show our blog entries. It does not exist to sort through our blog entries. So what we're going to do, if we go back here and look at here, we removed it a little bit. Now, we still called it, but we passed it something different, because what we did was recreated a helper up here at the constructor level to sort our blog, which does our actual sort for us. So all we have to do is call that blog.blog sorter down here and pass it to our blog.sort. So all that custom code that was here really belonged to the constructor level up here, because sorting the blog should belong with the blog itself, the blog constructor. So we moved that around and made that more efficient. Okay, now what we're doing in 12 is we're going to add the capability to do images. Let me just change my so see here, now I have an image up here. Okay, so let's see how we did that. We still have the date prototype. We still have down way at the bottom our HTML is still the same. Still have the random, still have the search blog, we still have the show blog. But let me show you what we did. So image, we added that. Remember I said optional items usually want to add in properties in order of importance. Image is optional, so it's not as important as body and date. So we put it at the end. So we added a property to our constructor. And then we had to change the way it's constructing so that if it has an image, it'll show up in our code. So we had to change our to HTML before. Let me find it in here. I passed it. Our to HTML, we had to highlight the gray and white, and then we just took that the date and the body and the signature and put it in there. But in version 12, what we had to do is we had to say, okay, does an image exist? Because remember, it's optional. We had to test to see if that image existed or not. If it does, if that returns true, then what we're doing is just using some concatenation. We add an image tag in here with our this.image property, do some styling and things like that, and we have our image. If it doesn't, we're using the same code we used before. So we're just testing to see if in our blog do we have any of these that have images, and we have one down here at the end that has an image in it. So we made it optional, and we could do this if statement so that we could have it display like this. So we could have the option to have an image. Now, this is a lot of code over the objects presentation, custom objects presentation that I've thrown at you. We're going on the vertical as far as complexity, and that's by design, and I would expect some questions and things. This is stuff that you're going to need to wrestle with if you're not familiar with it, and that struggle, that wrestling's a good thing, because you'll come out understanding it more and having a strong comprehension of how to do this. So I would encourage you to go through this blog code and work through it to see how it works, and if you have any questions, feel free to ping me. I'd be more than happy to help you. But at this point, we've got a blog application where we have things at the class object-oriented level, like a custom data object, our constructor with our properties, even an optional property. We've got a toString that's a class that's shared among instances. To HTML, it's a class shared among instances, class methods. Same thing with contains text. So this is very similar to the unitdata.js files you've used and I've used in some of the labs and in some of the assignments. So feel free to take a look at how I built those areas and how that is constructed, that code, because you may be able to emulate some of that and play with it and get familiar with how it works. We're opening the doors to you now with how do we build almost enterprise level JavaScript, object-oriented JavaScript. We're just cracking that door open. So what this does is it gives you a view into now we can really do some cool things because JavaScript is everywhere. I can build it client-side on the web. I can build it server-side. I can even build a web server using JavaScript, using Node.js, a JavaScript library. I can do grab frameworks and build interactive Ajax level of programs. I can even build desktop applications using this stuff. So we're opening that door there a little bit. So make sure you get familiar with this because when you get to the last project, you're going to need to know how to do some of this stuff to do it well. So go through this code. If you have any questions, let me know. I'd be more than happy to help you out. If not, happy coding.